I'm Nikki Lytle, a postdoctoral fellow at the Salk Institute in Dr. Geoffrey Wahl's lab. I wanted to first start my presentation today by thanking you so much for attending this event. And so what today I want to talk to you about is my work towards preventing pancreatic cancer metastasis. And I'm going to talk to you about this from the perspective as a mediocre at best gardener, and you'll see what I'm talking about. So here we have this very beautiful and elegant bright dandelion that we all know so well. And these dandelions are wonderful wonder flowers, but if you ignore them, they turn into this very problematic seed producing state, which is just this ball of fluffy seeds that are able to spread all over your garden. And if you ignore them, your lovely lawn will just become a lawn of dandelions. So I started doing research about dandelions, and what I found was that each dandelion plant produces up to 15,000 seeds, which is an extremely daunting number of seeds. But the good part is, on average, each plant of 15,000 seeds can only give rise to about 10 new plants. So this is an incredibly inefficient process, about a 0.05% success rate. Instead of trying to prevent those seeds from making new dandelions, an alternative approach is actually to make it so that the soil is very non-conducive to dandelion growth. And instead of your lawn just covered in dandelions, it's a pristine, perfect lawn that's free of these flowers. So why am I talking about dandelions? In a way, I see that analogy of dandelion spread is very similar to how cancer may metastasize to other organs throughout your body. So metastasis is the process of tumor cells leaving the primary tumor and entering circulation either by blood or by lymph, and then spreading to other organs in your body and establishing new tumors known as metastatic tumors. The reason why we care so much about metastasis is it's actually the #1 driver of all cancer-related deaths. And in recent years, we've now realized that the problem with trying to stop metastasis is that tumors will randomly shed into circulation very early in disease and spread throughout the body. So when a patient enters the clinic and has a new diagnosis of cancer, most likely that patient already harbors metastatic tumor cells throughout their body. So this again is a little daunting, similar to the way in which you think of those seeds of the dandelion just spreading all over your lawn. But the good news about cancer metastasis is that less than 0.1 or 1 in 1,000 of those cancer cells that spread are actually able to survive and give rise to new tumors. Again, this is very similar to the dandelion analogy. So if we continue in thinking about how we prevent dandelions from spreading, can we use a similar approach with tumor cells spreading through the body? Rather than preventing the spread of the seeds, i.e. the tumor cells, why don't we make it so that the soil is uninhabitable? So make it very difficult for those tumor cells to survive at distant sites. The pancreas is this funny banana-shaped organ that sits underneath the stomach, attached to the small intestine. And it critically shares a very important circulation system with the liver. So blood flows from the pancreas to the liver. And this is likely one of the reasons that liver is the #1 site of metastasis for pancreatic cancer patients. Additionally, and what's kind of important for us is that patients with liver metastasis have worse survival than patients with metastasis to other organs. But what was intriguing for me, and an additional piece of information, was that patients with liver damage specifically have increased incidence of metastasis as compared to patients with healthy liver. And this really suggested that it's possible that the damaged liver may be encouraging the growth of metastatic pancreatic cancer cells. And so thinking about this, if I was a pancreatic cancer cell that landed in a healthy sick liver versus a sick liver, I'm going to be getting different cues from the environment around me as to whether or not I should survive, or maybe even it's too stressful, I can't make it, and I die. So my hypothesis was that signals from the damaged liver may encourage the survival and outgrowth of metastatic tumor cells. But how can we test this? So we test this using mouse models, where I first introduce either them into a healthy lifestyle or a liver damaging lifestyle. I can then introduce pancreatic cancer cells in a way in which they preferentially go to the liver, so they metastasize to the liver. And then after that, I'm able to track both liver metastasis and survival in the mice that either had healthy liver or damaged liver. To my surprise, what I found was that it really matters what the source of liver damage is on whether or not progression of liver metastasis is faster or slower. However, in contrast, I tested a number of chemotherapies that are given to pancreatic cancer patients. And what I found was that one chemotherapy in particular drives a lot of liver damage. And after transplantation with pancreatic cancer cells, these mice with chemotherapy-induced liver damage died several weeks faster. And all told, they died about 36% faster than their healthy liver counterparts. So this chemotherapy really seems to be driving faster liver metastasis. So what do I do next? My first goal is to define which liver signals alter metastatic progression. Once we have an idea of what signals may be encouraging metastasis, we'd like to explore therapeutic approaches to block that liver-derived pro-metastatic signal. The goal is to develop a metastasis interception therapeutic approach. So the idea is to treat patients with therapies that target the liver to prevent metastatic outgrowth, along with their therapies that they would normally get. And what you can imagine is that this approach would make the liver this very fertile, lush soil that encourages metastasis to kind of a deplete soil that really dampens the ability of metastasis to grow out. So with that, I'd like to again thank you for attending the talk today. Big thank you to both my lab, Dr. Geoffrey Wahl, along with the people that help me with this work on a day-to-day basis, my other collaborators at the Salk Institute, and a huge thank you to Sky Foundation.